So hi everybody, in this video we will be going through few interconversions in carbohydrates. So first is from aldopentoses to aldohexose. So aldopentose consists of 5 carbon atoms. I mean its skeleton is 5 carbon atoms, and aldohexoses consists of 6 carbon. So it means essentially carbon chain has been from 5 to 6 carbon chain has been lengthened. So this is your this is called stepping up of series. Stepping up the series. So one of the method is your Kiliani Fischer synthesis. I'll just show with taking glyceraldehyde, D-glyceraldehyde, then converting it to D-triose and D-erythrose. Then we will do to your pentose to aldopentose to aldohexose. So the method is as follows. You start with your, suppose you start with your D-glyceraldehyde, which is given by OH. Now when you react it with hydrogen cyanide, okay, so what will happen is there are two possibilities, because now you have generated a new chiral center, so you end up getting a cyanohydrin, which is CH2OH, and its stereo isomer, which is a OH, CH2OH and nitrile. Okay, so the next step is your conversion of this nitrile group to carboxylic acid group. So this is done using your base hydrolysis, barium hydroxide, and second step is then acidification using H2SO4. So you know that base hydrolysis, and let me write it off, base hydrolysis converts nitrile group to carboxylic acid, to carboxylate ion, and then acidification converts to carboxylic acid. So carboxylate ion I will write. Okay, so this nitrile has been converted to your carboxylic acid group. Now what happens? Intramolecular reaction takes place, and this attacks this carbon electrophilic wall bonds, bond breaks and again falls back to kick out this particular hydroxyl group. So essentially what has happened is you have generated a lactone. Further what happens, you react it with sodium amalgam NaHg, presence of water and keeping pH, acidic pH of 3 to 5. So here what happens, free electron reduction using free electron transfer from sodium. Okay, so sodium is a alkali metal, it can give away one electron. So now what has happened, ester group will break into your aldehyde and your alcohol. So that is what reduction takes place here. So this is your D-arabinose. So essentially from you have stepped up, means you have increased the carbon atom in your carbon skeleton. So from glyceraldehyde, which is a triose, you have got tetrose. Okay, so this is what, so we'll repeat this whole thing here with your another stereoisomer. So first make it react it with base hydrolysis using barium hydroxide and then acidification using sulfuric acid H2SO4. So you have converted nitrile group to carboxylic acid group. So next step is your lactonization. Lactone is formed because this will go and attack this particular carbon, open up, close back and kick out this particular hydroxyl group. So your lactone is formed. So lactones are basically aromatic, not aromatic, cyclic esters. Same thing if you reduce it. Next step is your reduction using sodium amalgam with water and pH 3 to 5. So what you end up getting is your B, 3 use. Okay. So this was your Kiliani Fischer synthesis. So let us do it for aldopentose to aldohexose using the same method. So let us start with some aldohexose. CHO. I'll just write CHOH, 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 and CH2OH. So this is your aldopentose. React it with hydrogen cyanide, aqueous solution, aqueous. So what you end up is getting cyanohydrin, which CHOH, 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 and OH. So which means here a new steric center is generated. So which means Kiliani Fischer synthesis will give two products. Okay, this one when you react it with one barium hydroxide and again acidify using sulfuric acid. What happens? Conversion of this nitrile group to carboxylic acid group is done. So you get CHOH, 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 CHOH. Okay, this one you heat it. In presence of heat, what happens? Lactonization forms, lactone is formed. So what has happened is, so essentially this oxygen has gone and reacted with this carbon. Okay. CHOH, CHOH, CH. So theoretically, two lactones are possible because of the two steric centers. Okay. Next is your reduction using sodium, mercury, okay, and water. pH needs to be maintained from 3 to 5. So what you get is ester will reduce to aldehyde and alcohol. OH, CHOH, 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 and CH2. So which means now what you started with was aldopentose, you end up getting aldohexose. So that was about your stepping up of reaction, stepping up the series, Kiliani Fischer synthesis, and lengthening the carbon chain by 1. Thank you.